Before the universe became vast, before galaxies were known to fill the darkness, there was a time when humanity believed it already understood the cosmos. At the turn of the 20th century, astronomers looked up and saw a universe that felt contained. The Milky Way was believed to be everything, an enormous system of stars, yes, but finite. Beyond it lay mystery, certainly, but nothing that challenged the idea that our galaxy was the center of existence. This was the world into which Edwin Powell Hubble was born. He entered life on November 20th, 1889, in Marshfield, Missouri, a quiet town beneath wide, open skies. It was a place far removed from observatories and academic debate, where the stars were brilliant but distant, and the future seemed grounded firmly on Earth. Hubble did not begin as a dreamer of galaxies. As a boy, he was known more for his physical presence than his curiosity about the heavens. He was tall, athletic, disciplined. He boxed, ran, and competed fiercely. Teachers recognized his intelligence, but peers noticed his confidence. He carried himself as someone who expected to be taken seriously. His family reinforced that expectation. His father, an insurance executive, believed strongly in responsibility and practicality. Ambition was encouraged, but only if it led to stability. Science, particularly astronomy, was viewed as an interest, not a vocation. Edwin absorbed those values deeply. When the family moved to Chicago, new paths opened before him. He enrolled at the University of Chicago, where he studied mathematics and astronomy. There, surrounded by scholars and ideas, he encountered the vast questions of science for the first time. Questions of distance, of scale, of what lay beyond the stars. But the pull of expectation remained stronger than curiosity. Despite his academic promise, Hubble followed his father's wishes. After graduating, he earned a Rhodes Scholarship and traveled to Oxford University. There, instead of astronomy, he studied law and philosophy. He dressed formally, adopted English manners, and even cultivated a British accent, an outward transformation that mirrored his desire for legitimacy and respect. Yet inwardly, he was restless. The law did not inspire him. It felt narrow, procedural, disconnected from the deeper truths he had once glimpsed. For years, he continued anyway, honoring obligation over instinct. Then, in 1913, his father died. With that loss came freedom. For the first time, Edwin Hubble allowed himself to abandon the path laid out for him. He left the law behind and returned to the United States. To support himself, he taught high school physics and Spanish, a modest life for a man of his ambition. But during those quiet years, something important happened. He returned to astronomy. Hubble re-enrolled at the University of Chicago, this time pursuing a doctorate in the science he had never truly left behind. His focus turned to nebulae, faint, cloud-like objects scattered across the sky. Astronomers argued fiercely about their nature. Were they gas clouds within the Milky Way, or distant systems beyond it? The question was unresolved and dangerous. In 1917, Hubble completed his PhD. His work was precise, methodical, and ambitious. He seemed poised to begin a scientific career, until history intervened once again. The First World War had engulfed Europe. Hubble enlisted in the United States Army and served in France. He rose to the rank of Major, a title he would insist upon for the rest of his life. The experience hardened him, reinforcing his discipline and his sense of authority. When the war ended, Hubble returned to a world transformed, and so was astronomy. High above Los Angeles, on Mount Wilson, stood the most powerful telescope ever built, the 100-inch Hooker telescope. It could peer deeper into space than any instrument before it. Hubble was offered a position there. Night after night, he climbed the mountain and entered the silent observatory. Beneath the rotating dome, he stared into darkness filled with distant light. Among countless stars, he he focused on faint spiral nebulae, ghostly shapes barely visible against the void. Where others saw uncertainty, Hubble saw a question waiting to be answered. He worked patiently, quietly, carefully. And without realizing it, Edwin Hubble was approaching a discovery that would expand the universe itself. But the proof was still ahead. By the early 1920s, astronomy stood at a crossroads. For generations, scientists had believed the Milky Way was the entire universe, a vast but singular system of stars, surrounded by darkness. It was an assumption rooted not in certainty, but in limitation. Telescopes could see only so far, and beyond that boundary, speculation replaced evidence. Edwin Hubble intended to replace speculation with measurement. From his post at Mount Wilson Observatory, he worked night after night with the Hooker telescope, the most powerful eye humanity had ever turned toward the sky. The instrument allowed him to resolve details in distant objects that had once appeared as little more than smudges of light. His attention remained fixed on spiral nebulae. Many astronomers believed these objects were clouds of gas located within the Milky Way. Others suspected they might be something far larger, but lacked the evidence to prove it. The debate had grown heated, dividing the astronomical community. Hubble approached the question differently. Rather than arguing theory, he searched for stars. If individual stars could be identified inside these nebulae, their brightness could be measured. And if their brightness could be measured, their distance could be calculated. It was a simple idea, one made possible only by the unprecedented power of the Hooker telescope. Among the stars Hubble sought were Cepheid variables. These rare stars brighten and dim at regular intervals. Years earlier, astronomers had discovered a crucial relationship. The rate at which a Cepheid pulses reveals its true luminosity. By comparing that intrinsic brightness to how bright the star appears from Earth, its distance can be precisely determined. Cepheids were cosmic yardsticks. In 1923, while studying photographic plates of the Andromeda Nebula, Hubble noticed a faint point of light that seemed to change over time. At first, he labeled it a nova, a temporary stellar explosion. Then it brightened again, and again. The pattern was unmistakable. Hubble crossed out the word nova and replaced it with a single marking, VAR, variable. He had found a Cepheid. When Hubble calculated its distance, the result was staggering. Andromeda lay far beyond the outer limits of the Milky Way, so distant that it could not possibly be part of our galaxy. There was only one conclusion. The Andromeda Nebula was a galaxy of its own, an island of stars containing billions of suns, separated from the Milky Way by unimaginable distances of space. In 1924, Hubble published his findings. The long-standing debate ended almost instantly. The universe was no longer defined by a single galaxy. It was filled with galaxies. Humanity's sense of scale collapsed and then expanded beyond comprehension. Yet this was only the beginning. As Hubble continued observing distant galaxies, another pattern emerged. When astronomers analyzed the light from these galaxies, they found it was shifted toward the red end of the spectrum, a phenomenon known as redshift. Redshift indicated motion, specifically motion away from Earth. Hubble began comparing the redshifts of galaxies with their distances. As the data accumulated, the relationship became clear. The farther away a galaxy was, the faster it appeared to be moving away. In 1929, Hubble published his most profound discovery. The universe was expanding. Space itself was stretching, carrying galaxies along with it in every direction. The universe was not static, it was dynamic, changing over time. This single realization altered the foundations of science. It implied a universe with a beginning, a moment when everything was closer together. Though Hubble avoided speculation, his work laid the groundwork for what would later be known as the Big Bang theory. Fame followed, but Hubble remained reserved. He insisted he was merely reporting observations, not rewriting philosophy. Yet the truth was unavoidable. The Milky Way was not the center of the universe was not fixed, and humanity was not standing still in time. The cosmos was expanding, and Edwin Hubble had revealed it. But with discovery came consequence, and the final chapter of his life was still unfolding. By the 1930s, Edwin Hubble had permanently altered humanity's understanding of the universe. The Milky Way was no longer the whole of existence. Space itself was expanding. Galaxies were not fixed lights in a static sky, but distant systems rushing away from one another across a growing cosmos. These ideas reshaped astronomy and challenged philosophy, theology, and physics alike. Yet for Hubble himself, the years that followed were quieter and more complicated. Despite his fame, he remained a reserved and formal figure. He insisted on being addressed as Major Hubble, a title earned during his military service in the First World War. He valued discipline, precision, and restraint. Colleagues often found him distant, even intimidating. Hubble believed deeply that science should avoid speculation. Though his discoveries invited sweeping theories, he resisted them. He was uneasy with the growing enthusiasm for cosmological models and questioned whether redshift necessarily meant expansion. To him, certainty required evidence, and evidence demanded patience. In 1936, Hubble published The Realm of the Nebulae, a clear and authoritative account of his work. The book cemented his reputation as the astronomer who had revealed the true nature of galaxies. Yet even as his influence grew, a quiet absence followed him. There would be no Nobel Prize. At the time, astronomy was not classified as a branch of physics, and the prize committee did not recognize observational cosmology. Though Hubble's discoveries transformed physics itself, the honor he deserved never arrived. Those close to him sensed the disappointment, even if he rarely spoke of it. History, however, would find other ways to remember. When the Second World War began, Hubble once again served his country, contributing to military research involving ballistics and optics. Even during wartime, his focus remained fixed on measurement, on light, distance, and accuracy. After the war, he returned to Mount Wilson Observatory, continuing his work as new telescopes and new generations of astronomers pushed the field forward. His role gradually shifted from discoverer to elder figure, his earlier work forming the foundation upon which modern cosmology was built. In the early 1950s, Hubble's health declined. On September 28, 1953, he died suddenly of a cerebral thrombosis. He was 63 years old. There was no public grave, no marked resting place. In death, as in life, he remained private. But his legacy could not be hidden. Decades later, humanity launched a telescope beyond Earth's atmosphere, free from distortion, gazing deeper into space than any instrument before it. It was named the Hubble Space Telescope. Through it, astronomers observed galaxies forming near the beginning of time. They measured the age of the universe with increasing precision. They saw nebulae, black holes, and cosmic structures stretching across billions of light years. Every image traced its lineage to Edwin Hubble's original work. Every measurement echoed his central question: how large is the universe? Today, we know the universe is nearly 14 billion years old. We know it began in a hot, dense state and has been expanding ever since. We know there are hundreds of billions of galaxies, each filled with stars, worlds, and mysteries yet to be explored. All of this began with a man who chose distance over assumption, measurement over belief, evidence over comfort. Edwin Hubble did not place humanity at the center of the universe. He removed the center entirely, and in doing so, he revealed something greater than certainty. He revealed our capacity to understand the infinite. The universe continues to expand, and our understanding continues with it.